Welcome. So now we're going to solve a problem involving particle motion. And I'm going to add one extra question to this. We're going to find the average velocity of the particle during the first 2 seconds and find average acceleration during the first 2 seconds as well. All right, so let's look at the first one. All right, the position x-coordinate of a particle moving on an x-axis is by x of t equals t cubed minus 4t squared plus 3 for t greater than or equal to 0. So t is time, and then x of t is the position. Find the displacement of the particle during the first 2 seconds. All right, so we want to find out how far the particle moved. All right, that's all displacement means. All right, so let's see where, and it's this is always positive. It's distance. So it's always positive. All right, so let's find out where the particle is at t0. So at x of 0, the particle is at 0 cubed, or t equals 0. The particle is at 0 cubed minus 4 times 0 squared plus 3. Of course, it's at 3 units, whatever the units are. All right, so now let's find at 2 seconds. So that would be x of 2 equals 2 cubed minus 4 times 2 squared plus 3. All right, so that's going to be 8 minus 16 plus 3. So that's going to be at negative 5. All right, so the displacement it's always going to be the absolute value of the difference between those. All right, so if ending position is at negative 5, starting position was at positive 3, so we're taking away 3. That's going to give us 8 units. Right, and it's basically just the difference between negative 5 and 3, right, which is 8 units. So just remember displacement is positive, distance is positive. All right, so now let's find the average velocity of the particle and the average acceleration during the first 2 seconds. If we're finding an average, that equals the slope of the secant line. Right? So to find average velocity, we find the slope of position. Right? So, which means we're gonna take. I need more space. There's so little space here. We're going to find, so it's during the first 2 seconds, we're going to take s of 2 and subtract, oh, in this case it's hard, it's x. Let's get our equation right. So x of 2 minus x of 0 divided by 2 minus 0. That would be average velocity. We already know x of 0 is 3 units. We'll need to find x of 2. And since there's not a lot of space, how about we use the space up here for some calculating. So x of 2 is 2 cubed minus 4 times 2 squared plus 3. So that's going to be 8 oh, wait, I'm sorry, did we find? Oh, we already found that. Never mind. I'm like, these numbers sound really familiar. Sorry, we found that as well up there. So this is just going to be x of 2 was negative 5. Negative 5 minus 3 divided by 2 minus 0. That's going to be negative 4 units. And let's call it t seconds. So units per second. There we go. Now, to find average acceleration, we're going to need to find the first we have to find the velocity curve so that we can find out what v of 2 and v of 0 is, because average velocity is going to be this, average acceleration is going to be the slope of the velocity curve. Right, so this is slope of velocity. All right, and so we'll come right back to that question. Let's first, though, we're going to find instantaneous velocity, and then once we have the velocity curve, then we can find the average acceleration. So velocity, the function for velocity, we just take the derivative, would be 3t squared minus 8t. And of course, the derivative of 3 is going to be 0. So now for average acceleration, we're going to find, oops, I guess I'll stay in my green up here. We're going to find v of 2 minus v of 0 divided by 2 minus 0. So that will be our average acceleration. So that's going to be, so v of 2, well, v of 0 is 0. And v of 2 is going to be 3 times 2 squared minus 8 times 2. So that's going to be, so that would be 12 minus 16, so that's negative 4. Right, so our average acceleration is negative 4 minus 0 divided by 2 minus 0, which is negative, I squeeze it in there, I need just a little bit more space for the units. Negative 2 units per second squared. All right, so average velocity is the slope of the position function. We find the average rate of change for position. Average acceleration, we find the average rate of change with using velocity. If we wanted to find average jerk, then we would find the equation for acceleration, and we would find the average rate of change in the acceleration, and that would be jerk. Right, and so the average rate of change, right, is always the slope of the secant line. The instantaneous rate of change, we take the derivative and we plug directly into the derivative. Right, so v of 4 is 3 times 4 squared minus 8 times 4. Right, so this is going to be 16 times 3. That's going to be 48 minus 32. So that is 16 units per second. Right? And that's the instantaneous. So at the moment 4 seconds has gone by, right, the particle is moving 16 units per second. During the first 2 seconds, right, the average rate of change, the average velocity is just going to be the average rate of change in the position. During the first 2 seconds, the average acceleration is just the average rate of change in the velocity. And I didn't, I labeled here that t was going to equal seconds, and then it says it right here that the units for the time is. Well, it's a good thing I said seconds. I guessed that one right. Let's do two more problems. Let's find the acceleration of the particle when t equals 4, and then we have a long problem in finding, describing the motion of the particle. All right, so acceleration of the particle, we find the second derivative. So a of t is going to be 6t minus 8. We just take the derivative of velocity. And so we wanted a of 4, the instantaneous acceleration when t equals 4. That would be 6 times 4 minus 8. So that's going to be 24 minus 8. That's going to be 16 units per second squared. All right, so now let's describe the motion of the particle. All right, so we're going to talk about when is it moving right. So if we describe the motion of the particle, we want to know right and left, speeding up, slowing down. To find the right and left, right, we need to find when v of t equals 0. And then we can analyze to the right, and we can analyze on either side of those values. All right, so we're going to set v of t equal to 0. So 0 equals 3t squared minus 8t. All right, so we can factor out a t. We have 3t minus 8. So we have two solutions, t equals 0 and t equals 8/3. So the t equals 0, both of them are technically critical points, but t equals 0 is an endpoint critical point. It's not going to change directions when it just starts out, right? It's going in a direction. So it's not really changing direction, it's just starting a direction. But these are our critical points for velocity. They're the only places where the particle can change direction. And since t equals 0 is the beginning, the only one that's going to matter is the t equals 8/3. The endpoint's not going to matter in this situation because there's no values of t less than 0. All right, so we found that. To determine speeding up and slowing down, we're going to have to find two things. We're going to have to find when a of t equals 0 and compare sign for v of t and a of t on either side of critical points. I think I'm going to have to extend the page. I don't see me fitting everything in that little bit of space. All right, so let's find when a of t equals 0. Maybe I should have made this a different color. Oh, it's all one. Let's make that blue just so it stands out. Well, I can't hit it on the screen because my orientation's a bit off. Oh, I guess it's not going to change colors for me. It's all right. Actually, let's do this. There we go. Now it stands out a little bit from the solving for v of t. All right, so now let's set when a of t is 0. So we have the equation for acceleration was 6t minus 8. So 0 equals 6t minus 8. 8 equals 6t. Divide by 6, and that's going to be 8/6 or 4/3. All right, so this is another critical point. So this is a critical point, and this is a critical point. We have one for one meaningful one for velocity, and we have one for acceleration. So now let's create a sign chart. We're just going to have every color in this problem. All right, so we have v of t, and we have a of t. All right, and so v of t, we're going to need to worry about the point 8/3. And for a of t, we're going to need to worry about the point 4/3. we're going to have to worry about 4/3. Now, these are zeros for each of the two functions respectively. What we're going to have to worry about is we're going to have to worry about what's the sign on either side of the critical points for both acceleration and velocity. Right? So we're going to have to take kind of their critical points together and determine what's the sign of velocity and what's the sign of acceleration on either side of both critical points. Right? So the 0 is for, that 0 by the way is for, oops, well they're connected. That's for acceleration, right? Because that's a critical point for acceleration. That's when acceleration is 0. This 0 is a critical point for velocity. All right, so now let's plug in two values into the velocity equation. Let's plug in a value that is less than 4/3, and let's plug in a value that's between 4/3 and 8/3. All right, so less than 4/3, how about 1? Between 4/3 and 8/3, how about 2? All right, and by the way, their sign is going to be the same because the only place the sign of velocity can change is at 8/3. So really, if we plug in 1, we plugged in both because they're both going to have the same signs. Right? You can only a function can only change signs after critical points on either side of a critical point. So every value on one side of a critical point is going to be having the exact same sign. But we'll plug them both in because it's really easy just to do that. And then you can just see it. Yeah, they're going to have the same sign. So if I plug 1 into 3t squared minus 8t, that would be 3 minus 8, and that's -5, and that's negative. And I don't really care what the number is. I just care about the sign. If I plug 2 into 3t squared minus 8t, we would have 12 minus 16. That would be -4 if we really cared what the number was. Right? So the velocity is negative, which means the particle is moving to the left. Right? So by our sign chart here, we've established two things. We wanted to figure out right and left, and we wanted to figure out speeding up, slowing down. Right? So first of all, we have now figured out right and left for at least half our graph, because right here we are moving to the left. Right? That would be movement to the left. And we know it's to the left because velocity is negative. Let's plug in a value on the other side. Right? So a value greater than 8/3. How about 3? 3 is greater than 8/3. Right? So if we plug in 3, we would have 27 minus 24. That's positive. All right, so we see we're moving to the left before we get to before t is 8/3, and then we see we're moving to the right for t greater than 8/3. So we'll write that up. Let's find acceleration, and then we'll also have speeding up and slowing down. All right, so now we need a value that is less than 4/3. How about 1? 1 works very nicely again. And then we need a value greater than 4/3. How about 2? And a value that's greater than 8/3, because we have to consider the critical point for velocity. Right? We have to check velocity and acceleration on either side of the critical points for both of them. So let's check 3. Right? Same values. All right, so if we plug 1 into acceleration, we get -2. That's negative. So here you can see they're both negative. That would be speeding up. So I'm just going to put SU underneath it, and SU is going to stand for speeding up. And I'm going to give ourselves a little bit more space. If I can find the cursor, there it goes. This computer likes to lose its cursor. So this is speeding up because they have the same. All right, so how about at 2 seconds? If we plug 2 seconds into acceleration, we have 12 minus 8. That's positive. All right, so notice that 1 is positive, 1 is negative. All right, so if we compare right here, velocity is negative at t equals 2 seconds. Acceleration is positive. We are slowing down. If we plug in 3, we'll have 18 minus 8, that is positive. And it should be positive, right? Because the only place we're going to change signs is at 4/3. Because 8/3 is not a critical point for acceleration, it's a critical point for velocity. So notice they are the same, and we are speeding up. So let's write the motion of our particle here. The particle is moving to the left from t equals 0 until t equals 8/3. And we know that because we always want to justify, because velocity is negative, right? So the direction is to the left if velocity is negative. The particle is moving to the right for t greater than 8/3, because v of t is greater than 0, right? So it's moving to the right if velocity is positive. The particle is speeding up from, I'll just put it as an interval, 0, because we have 2 intervals here. So from 0 to 4/3, and from 8/3, and for t greater than 8/3, because we don't really know how long. It's just forever right after that, right? And t greater than 8/3. Is the particle moving forever and ever? I don't know. But as long as it's moving, it's going to be speeding up, and that's because v of t and a of t have the same sign. And that sign is positive. Actually, sorry. It's positive, but only for t greater than 8/3. It's negative from 0 to 4/3. It doesn't matter what the sign is. They just have the same sign. If they have the same sign, right, we're speeding up. We leave it at that. The particle is slowing down from 4/3 to 8/3. Because the signs of velocity and acceleration differ. So add this to your notes, including the average acceleration. I wanted to highlight the difference between average velocity and average acceleration, and how to describe the motion of a particle. So here we have a complete analysis of the motion, including direction and slowing up and speeding down, right? And that's the end of this podcast. So thanks for watching, and bye for now.